Well, good morning. It's time to do go over the review questions because we're coming up on the test. So the test will be in a day or two. All right. So make sure you check on Canvas as to when that's going to be. But so hopefully you did your review, and now it's time to go over the right answers. So first one says terms to know for the test. And it has symbols for the following. Well, aqueous, the symbol for aqueous is you put in parentheses, you put a lowercase aq. Now remember, it's lowercase, it's not capital. And aqueous means something that is dissolved in water. So think of the idea of Kool-Aid. We could actually say Kool-Aid is actually aqueous sugar. All right, so it's sugar with an aq after it, meaning that we have sugar dissolved in water. Second one, letter B, precipitate. For that one, again, put it in parentheses, and you put a lowercase p-t. Excuse me, goodness, man. So it's a lowercase ppt, or what also you could use is you can actually use an arrow that points downward. And that reason is because what a precipitate does is when it's sitting in water, commonly what it does, it actually settles and sinks to the bottom of the water. Right? So that's another reason why they'll use an arrow that goes downward. Gas, you put in parentheses, put a lowercase g. All of these, I will point out, all of these have to be lowercase. Don't make them a capital. If you make them a capital, then it looks like an element. All right, and that's why we use lowercase on all of them. For liquid, it's a lowercase l. All right, commonly actually a cursive L going like this. You could use just a basic L, which is straight up and down. Sometimes that would look like a 1, but it is just a lowercase l. Letter E, a solid, is a lowercase s. And then letter F, what a catalyst is something that helps out a reaction, but isn't part of the reaction. So what you do is on the arrow that's in the reaction, you put the word on top of it, whatever that catalyst might be. A common one that you may have experienced in biology would be chlorophyll. When we look at the reaction for photosynthesis is in plants where we take carbon dioxide plus water, and then the presence of chlorophyll, so you have the arrow, and then you put the word chlorophyll on top, saying that, well, plants got to be green in order for it to carry out photosynthesis. If it's not green, it's not going to do it, and it's going to die. So we have chlorophyll there. That's a catalyst that helps it so that it can make over on the other side sugar and give off oxygen. And that's the process of photosynthesis. So that's what a catalyst is. It can be other things. We can have magnesium be a catalyst that helps a reaction. You can have water be a catalyst. And any one of those, what they do is they write them above the arrow to indicate that it's there to help the reaction, but it's not actually part of the reaction at all. It doesn't add to the products. All right, number 2, what's a balanced equation? What are we trying to do? We're trying to get the stuff that's on the left hand of the equation to equal the atoms that are on the right hand side, so that I'm not creating nor destroying matter. All I'm simply doing is rearranging it when I go from one side over to the other. That's what a balanced equation is. All right. Now, what's a hydrocarbon? Hydrocarbon is a compound that contains exactly what the word says, hydrogen and carbon. So it's anything that has hydrogen and carbon. It can also have oxygen in it, but it doesn't have to have oxygen in it. Molecules. Molecules are the big numbers that we keep writing out in front. When we put a 2 out in front, or a 3, or we leave it blank, which means it's a 1. Those are molecules of that substance. Right? That's why I have molecules down. Products are the things that we're forming. That's the stuff that's on the right-hand side of the equation. Reactants, those are the things that we're doing the reacting. That's the stuff that's on the left-hand side of the equation. Then we have the law of conservation of mass. What that says is what I said earlier when I talked about balanced equations, and that is that matter can neither be created nor destroyed. All we're simply going to do is rearrange matter in chemical reactions. All right? Now, also understand that these chemical reactions we're doing balancing reactions. What we balance doesn't tell the reaction what to do. Now, if it doesn't tell it, the reaction is going to do what it's going to do. All the balanced equation does is it helps us understand what happened in front of us. When we put two chemicals together, what actually occurred and what was the ratio of the different elements that were present in order to get whatever the products were. So in the case of the rust that's on my truck, unfortunately, what's the ratio of the iron that was present in my truck and the oxygen that was in the air that combined to make the rust on the other side, or iron oxide, Fe2O3. So what was the ratio of those two to get in there? All right, that's what this balancing equation stuff is all about. All right, number 8, examples of each type of reaction. What you could do on this one is you can just give me a generic way of writing these for the combination synthesis. That's when we took A plus B and it forms the compound AB. When AB went together and all of a sudden they're together, we have to do the crisscross method to come up with the formula. Then you got decomposition, that's the reverse. You take compound AB and break it apart and it turns into A plus B. We tear it apart and end up with two elements separate from each other. Right? Then we had single replacement. Single replacement, we have element A plus the compound BC. And that's going to form, if A is positive, then we end up with B all by himself plus AC. All right, so the positive two traded places. So that's why we ended up with B all by himself. And now we got A in with C. Now we can have D, which is negative, combined with BC. And now which one's he going to kick off? Well, he's going to kick off the negative one. So the C is going to end up all by itself. Plus we're going to get B joined up with D. Remember, this is only because it's negative. This is because he's positive. All right, then double replacement. Double replacement, you have AB plus CD. And these ones, the two positives, trade places. So we're going to put C with B plus A with D. All right? And remember that when you write these, it's always the positive one first and the negative one second. Because this one here seems backwards having C and B. But notice over here, B is negative, C is positive. So that's why we put the C first. And then my last one, combustion. You take a hydrocarbon, something that's got carbon and hydrogen in it. You're always going to combine it with oxygen, and it's going to form carbon dioxide and water. Always. Right? As long as we're doing complete combustion. That's the one piece I got to always say. Because if it's incomplete, which is what occurs in our car, we don't burn the hydrocarbon, the gasoline entirely, then I don't end up with carbon dioxide and water. I get carbon monoxide and a bunch of other stuff. Right? As long as we burn every single bit of that hydrocarbon, we get carbon dioxide and water if we burn it in the presence of enough oxygen. All right, so those are the terms. All right, well now let's go to balancing the following reactions. I'm going to move the camera so that I can put this up above so I don't have to hold my arm up above. So let me erase all these guys. And then you guys are going to go for a ride because I'm going to move the camera over. All right, hold on because here we go. All right. Let's see if I can get you a level. There we go. All right, so now the first one, we have C2H2 plus O2, and that forms CO2 plus H2O. Now, something else to look at this was not part of your review, but I'll point it out anyway. What type of reaction is this? If you go back to the ones just before this, we had combination, decomposition, single replacement, double replacement, combustion. Well, this one's a combustion. How do you know it? There's the hydrocarbon. Combine it with oxygen, we're making carbon dioxide and water. One of the key things you can look for is look for these two guys over here. If we get carbon dioxide and water, then it's probably combustion. All right, so if we balance this guy, I got two C's, two H's, plus I got two O's. That's equal to a C and two O's plus two H's and an O. All right, so start with the C's. 1, 2, I got 1. So I need another one of this guy. There's my two C's. H's, I got 1, 2. Oh, I got 1, 2. Okay. O's, I got 2, but on this side I got 1, 2, 3, 4, 5. Oh, nuts. It's an odd and even. So that means come back to this one, double it. Start all over. Now I got 1, 2, 3, 4 C's. So I need some more C's. There's my 4 C's now. H's, I got 4 H's. Oh, I only got 2 H's, so I need some more. There's my 4 H's now. Now we'll do O's. I got 2. On the other side, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need some more. There's 4, there's 6, there's 8, and there's 10. So there's my final thing. Now, if you remember in the terms, we talked about molecules. So I'm going to put my number of molecules. 1, 2, there's 2. 1, 2, 3, 4, 5, there's 5. 1, 2, 3, 4, 4 molecules. And 1, 2, 2 molecules. So those big numbers out in front tell me how many molecules there are of each one. All right, on to the next one. All right, next one, C3H8. Plus O2 forms CO2 plus H2O. Oh, what type is this one again? Oh, this one's again combustion because we end up making carbon dioxide and water. All right, so we got 3 C's and 8 H's plus 2 O's. That's equal to a C and 2 O's plus 2 H's and an O. So I got 3 C's, I got 1 C, so I need some more C's. There's 2, there's 3. So I got my 3 C's now. H's, I got 8 H's, and I got 2. So I need some more. There's 4, 6, there's my 8. Now I'm up to O's, 1, 2, and this side I got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I got 10, so I can make this 10. There's 4, there's 6, there's 8, there's 10. So there's my final answer. I got 1 of this, leave it blank. 1, 2, 3, 4, 5, so put a 5 molecules there. 1, 2, 3, put a 3, and then 1, 2, 3, 4, and 4 molecules of him. So there's my final one on that one. All right, on to the next one. All right, we got RH03, and that breaks down and becomes RHO plus O2. All right, what did this one do? Well, we started with 1 compound on this side, and we ended up making 2, so this is decomposition in this one. All right, so let's balance this guy. I got an RH, and I got 3 O's. That's equal to an RH and an O plus 2 O's. All right, so I got 1 RH, 1 RH. I got 1, 2, 3 O's. On this side, I got 1, 2, 3. That one's already balanced the way it sits. I don't have to do anything. It's a 1 to 1 to 1 ratio of molecules. All right, so that one's done. Last one of these. All right, this one, we got O2 plus SB2S3, and that's going to form SB2O4 plus SO2. All right, this one's unique, so we aren't going to worry about what this one is. It's not. It doesn't fall into really any of the categories we got. But we're still going to balance it. So we've got 2 O's plus. We got an SB and an SB and 3 S's equal to an SB and SB, 4 O's plus an S and 2 O's. Whew. Now don't get those SB's and the S's mixed up. But skip the O's, do the SB's. Got 1, 2, got 1, 2. That's good. I got 3 S's, I got 1 S, so I need some more S's. There's 2, there's 3 S's. All right, now I do my O's. I got 2 O's. On this side, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew. Amen, 10. So we need, there's 4, there's 6, there's 8, and there's 10. So we're all even. So we got 1, 2, 3, 4, 5. 5 molecules again. 1, leave it blank. 1, leave it blank. That's 1. 1, 2, 3, put a 3, and there's my 3 molecules. All right, we're going to stop there, and we're going to do part number 2. So we'll see you in part number 2.